Hello students, in the previous lecture we started with the study of some commonly used salts. In that we studied about common salt, that is sodium chloride, and in this lecture we will study some more commonly used salts. So let us study about the second salt, that is bleaching powder. So let us study about bleaching powder. So students, the second salt that we are going to study is bleaching powder. Bleaching powder. Students, bleaching powder is represented by the formula CaOCl2. And students, the chemical name of bleaching powder is calcium oxychloride. So its chemical name is calcium oxychloride. So students, bleaching powder is represented with the formula CaOCl2, whose chemical name is calcium oxychloride. First of all, let us study about the preparation of bleaching powder. So first of all, the preparation. Students, bleaching powder is prepared by the action of chlorine gas, which is obtained by the electrolysis of sodium chloride. As students, you remember, upon the electrolysis of brine solution we get chlorine gas. So students, this bleaching powder is obtained by the action of chlorine gas on dry slaked lime. So let us see how this bleaching powder is prepared. Let us see the reaction. So if we have dry slaked lime, students, slaked lime is calcium hydroxide, calcium hydroxide. Students, this is slaked lime. The common name is slaked lime. So students, upon the action of chlorine gas on slaked lime, we get bleaching powder, which is having formula CaOCl2 along with the formation of water. So students, what is this? This is calcium oxychloride and it is commonly known as bleaching powder. So students, that's how we get bleaching powder. I hope students, the preparation of bleaching powder is clear. So when chlorine gas reacts on slaked lime, we get bleaching powder. Now next, what are the properties and uses of bleaching powder? First of all, the properties. So what are the properties of bleaching powder? Students, when we talk about the properties of bleaching powder, first of all about its state, its color. Students, it is a white powder which is having strong smell of chlorine. So first property is that it is white colored powder, white powder with smell of chlorine. Students, why the smell of chlorine is there in the bleaching powder? Students, when bleaching powder is exposed to the air, then it reacts with the carbon dioxide present in the air and it liberates the chlorine gas. Let us see the reaction, what actually happens on exposure of bleaching powder to the air. So students, the bleaching powder is represented by the formula CaOCl2. When it reacts with the carbon dioxide present in the air, it actually liberates the chlorine gas. Now students, what are the products obtained? One product obtained is calcium carbonate and chlorine gas is liberated. That's why we can smell of chlorine gas. So students, first property is that it is a white powder which is having the smell of chlorine gas. Now students, second property, it is soluble even in cold water. So second property is that it is soluble in cold water. Students, as such it is soluble even in cold water, but slight milkiness is seen. That is because of the unreacted lime which is present in bleaching powder. Now third property, it reacts with dilute acids to form chlorine gas. So students, when dilute acids react with the bleaching powder, then chlorine gas is liberated. Let us see an example here. So we have bleaching powder with the formula CaOCl2. Let us take the acid, let us take sulfuric acid. Now students, when sulfuric acid dilute form is taken, so when it reacts with the bleaching powder, let us see what all do we get. We get, students, calcium sulfate along with the formation of water, and students, in this reaction chlorine gas is liberated. Students, here the dilute acid which we took is sulfuric acid. Even if we take hydrochloric acid, then it also liberates the chlorine gas. So students, these are the three main properties of bleaching powder. First of all, it is a white colored powder with a strong smell of chlorine. Second, it is soluble even in cold water. Third is that if it reacts with the dilute acids, it liberates chlorine gas. Now students, next, what are the uses of bleaching powder? So, let us know about the uses of bleaching powder. Students, when it comes to the uses of bleaching powder, first of all, the very common use, obvious use is that it is used for the bleaching purpose. So first use is that it is used in bleaching. Bleaching wood, clothes, linen, etc. Students, obvious use is that if it is bleaching powder, it is obviously used in the bleaching process. So students, second use is that it is used as oxidizing agent in the industries. It is used as oxidizing. It is used as an oxidizing agent in industries. Students, I hope you remember what are oxidizing agents. Oxidizing agents are the ones which oxidizes other substances. Now students, the third use. It is used in the formation of chloroform. Students, I hope you must have heard of the word chloroform. Chloroform is having formula CHCl3. So students, it is also used in the formation of chloroform. The fourth important use is that it is used as a disinfectant. As a disinfectant. Students, it is used as a disinfectant to make water free of germs. To make water free of germs. And students, this disinfectant property of bleaching powder is also because of the chlorine gas. Now students, one more thing we can see here. The property we studied, that it reacts with the dilute acids to produce the chlorine gas. Students, generally the bleaching action of the bleaching powder is because of the available chlorine. When we take more amount of the acid, it actually liberates whole of the chlorine gas. And whole of the chlorine gas that is liberated, that is actually known as available chlorine. And the bleaching action of the bleaching powder depends on the available chlorine. More is the available chlorine, better is the bleaching powder, and higher is its price. And students, the good quality bleaching powder which is available in the market, that actually contains 35% to 38% of available chlorine. So students, I hope this bleaching powder is clear to you. Next we will study what is washing soda. Now students, let us study about the third salt, which is washing soda. So let us study what is washing soda. Third salt we are going to study is washing soda. Students, washing soda is having formula Na2CO3.10 water molecules. So students, the molecular formula or the chemical formula of washing soda is Na2CO3 dot 10 water molecules, and the chemical name of washing soda is sodium carbonate. Sodium carbonate decahydrate. Students, here deca stands for 10 water molecules. So students, the chemical name of washing soda is sodium carbonate decahydrate. So students, first of all, let us study about the preparation of washing soda. So let us study about the preparation first. Students, actually this washing soda is prepared in various steps. So let us know about those steps. First step. Students, step 1 is the manufacturing of sodium bicarbonate, or which is sodium hydrogen carbonate. So first step is the manufacturing of sodium hydrogen carbonate. And students, you know that sodium hydrogen carbonate can also be written as simply sodium bicarbonate. So students, first step includes the formation of sodium hydrogen carbonate. Let us see. So students, in this step, sodium hydrogen carbonate is obtained by the reaction of sodium chloride with ammonia along with carbon dioxide and water. So let us see how the sodium hydrogen carbonate is obtained. Sodium chloride reacts with ammonia, carbon dioxide and water, and when these four react with each other, we get sodium hydrogen carbonate along with the formation of ammonium chloride. So students, let us see how the sodium hydrogen carbonate is obtained. When sodium chloride reacts with ammonia, with carbon dioxide and with water, we get two products. One is sodium bicarbonate. This is sodium bicarbonate, which is also known as sodium hydrogen carbonate, along with the formation of ammonium chloride. Now students, sodium hydrogen carbonate and ammonium chloride differ in their properties. Sodium hydrogen carbonate is sparingly soluble in water, or which means that it is only partially soluble in water. It is sparingly soluble in water. Sparingly soluble in water. Whereas students, ammonium chloride is soluble in water. So students, as these two products differ in their properties, so we can separate these two products easily. So students, as sodium hydrogen carbonate is sparingly soluble in water, so it is obtained as a precipitate. It can be filtered out and then it can be even dried. So students, I hope it is understood to you that the formation of washing soda includes various steps. First step is the manufacturing of sodium hydrogen carbonate. And students, sodium hydrogen carbonate is obtained along with the formation of ammonium chloride. This is sparingly soluble in water, so we can easily separate it out. Now students, let us study what is the second step. Students, the second step is the thermal decomposition of sodium bicarbonate. So in the first step, we obtain sodium bicarbonate, and second step, students, is the thermal decomposition of sodium bicarbonate, which we obtained in the first step. Now students, let us see what happens upon the thermal decomposition of sodium hydrogen carbonate. So this is the formula of sodium bicarbonate. When it is strongly heated, this sign shows heating. Now upon its strong heating, what all do we get? We get sodium carbonate with formula Na2CO3 along with the formation of carbon dioxide gas. It is evolved along with the formation of water vapors. So I can show the sign this along with water also. So students, let us see. This sodium hydrogen carbonate was in the solid state. Upon the thermal decomposition of sodium hydrogen carbonate, we get sodium carbonate, which is in the solid state, along with the evolution of carbon dioxide and water vapors. So students, upon balancing this equation, I need to add 2 coefficient here. So this equation is now balanced here. Now students, this sodium carbonate which is obtained here, it is actually anhydrous. Anhydrous means which contains no water molecules. It is in the anhydrous form. Anhydrous sodium carbonate. Sodium carbonate. So students, upon the thermal decomposition of sodium hydrogen carbonate, we get anhydrous means which contains no water molecules. Anhydrous sodium carbonate is obtained. Now students, this anhydrous sodium carbonate is also known as soda ash. Now what about the third step? Let's study about the third step. Step third, students, include the recrystallization of sodium carbonate which is obtained. So this step includes recrystallization. Recrystallization of sodium carbonate which is obtained in the second step. So this step includes the recrystallization. So students, the sodium carbonate which is obtained in the second step, that is dissolved in water and later it is recrystallized. Now let us see what happens upon recrystallization. So we have sodium carbonate. When it is dissolved in water, we get, students, we get washing soda with formula Na2CO3 along with 10 water molecules. Now students, this what we have obtained is washing soda. So students, when the sodium carbonate is dissolved in water and it is recrystallized, we get sodium carbonate 10 water molecules, and it is the chemical formula of washing soda. So students, upon balancing this equation, we need to add 10 coefficient here. So students, I hope it is clear to you how washing soda is obtained. It is obtained in 3 steps. First, the formation of sodium hydrogen carbonate, which is later thermally decomposed to get sodium carbonate, which is anhydrous form, also known as soda ash. And students, when the soda ash is dissolved in water and recrystallized, we get washing soda. Now students, one thing we can see here, that what are these 10 water molecules? Students, these 10 water molecules are actually the water of crystallization. Let us know what are water of crystallization. What is water of What is water of crystallization? Students, this water of crystallization, it is a fixed number of water molecules which is present in one formula unit of the salt. It is a fixed number of water molecules. So, it is fixed number of water molecules present in one formula unit of salt. Students, actually these water of crystallization are nothing but the number of water molecules which are required to obtain a perfect crystalline structure by the salt. Students, every salt requires different number of water molecules, but for each salt this number is fixed. As we can see here that in this washing soda, the number of water molecules is 10, and these 10 number of water molecules are known as water of crystallization. So students, I hope this preparation of washing soda is clear to you. Next we will study the properties and uses of washing soda. Now students, let us study the properties and uses of washing soda. So, first of all, let us study the properties of washing soda. Students, when we talk about the properties of washing soda, first of all, students, when this washing soda is freshly prepared, it is actually transparent crystalline solid. So first property is that it is a transparent crystalline solid. Now second property is action of air. Second property is action of air. Students, when washing soda is exposed to air, then it loses its 9 water of crystallization. It loses 9 molecules of water of crystallization. So students, we can write here it loses 9 molecules of water of crystallization. In total, students, it has 10 molecules of water of crystallization, and students, on exposure to air, it loses its 9 molecules of water of crystallization. So what actually happens? So we have washing soda with formula Na2CO3 dot 10 water molecules, and when this is exposed to air, it loses its 9 molecules of water of crystallization. So what we are left with? Na2CO3 dot 1 molecule of water of crystallization, and it loses 9 molecules of water of crystallization in the form of water vapor. So students, this phenomenon, when a hydrated salt loses its water of crystallization upon exposure to air, this phenomenon is known as efflorescence. So students, this actually phenomenon is known as efflorescence. So students, on exposure to air, this washing soda loses its 9 molecules of water of crystallization. Now third property is action of heat. Action of heat. Students, when washing soda is heated, it does not decompose. It actually loses its all the molecules of water of crystallization, loses all molecules. All molecules include 10 molecules. It loses all molecules of water of crystallization. So it loses all molecules of water of crystallization on heating. So we have washing soda Na2CO3 dot 10 water molecules, that is sodium carbonate decahydrate. Students, this salt, when contains water of crystallization, such salt is known as hydrated salt. So here I can write that this is hydrated salt, and this hydrated salt on heating loses its all water of crystallization. So what do we get? We get sodium carbonate along with 10 molecules of water of crystallization, which are evolved in the form of water vapors. So students, on heating this washing soda, it changes from its hydrated state to anhydrous state. So what do we get? We get anhydrous salt on heating. Anhydrous salt. So students, on action of the air, washing soda does not decompose. It actually loses its water of crystallization. So it changes its state from hydrated salt to anhydrous salt. Hydrated salt is the one which contains water of crystallization, and anhydrous salt is the one which does not contain water of crystallization. So I hope students, this action of air, action of heat is clear to you. Students, fourth property is that its aqueous state, its aqueous solution is alkaline in nature. If it is alkaline in nature, it will change red litmus solution to blue. So students, the aqueous solution of washing soda is alkaline in nature. Let us see how. Students, if we have washing soda, I am writing the anhydrous form, Na2CO3. Now when it reacts with water, this is actually salt hydrolysis. So when salt hydrolysis occurs, we get a base and an acid. So students, the base which we get is sodium hydroxide along with the formation of acid, which is carbonic acid with formula H2CO3. Now students, we can see here this reaction is actually salt hydrolysis. This salt, when reacts with water, we get a base and an acid. Now one thing we can clearly see here, that the base which is obtained is a strong base and the acid which is formed is a weak acid. So this is a strong base. And students, this is a weak acid. And students, obviously when the base is strong and the acid is weak, overall the solution is alkaline in nature. Now students, if we need to balance the equation, I need to add 2 coefficient before water and 2 coefficient before this base. Now students, the equation is balanced also. I hope it is clear why the aqueous solution of washing soda is alkaline in nature. Now students, the fifth property. Students, fifth property is that it has cleaning action, obviously as the name suggests. So it has a cleaning action by attacking, as it attacks dirt and grease and make them water soluble, and as it makes these grease and dirt water soluble, therefore these can be removed by water. So students, I hope these properties of washing soda are clear to you. First of all, we studied about that its state is transparent crystalline. It is a transparent crystalline solid. Second is its action of air. Third, students, is action of heat. And fourth, we studied is that aqueous solution of washing soda is alkaline in nature. And students, the fifth property is its cleansing action, as it attacks dirt and grease and make it water soluble, so therefore it can be easily removed with the help of water. So these are the properties of washing soda. Next are the uses of washing soda. Let us study about the uses of washing soda. Students, first of all, as the name indicates, it is used as a cleansing agent in domestic purposes. So it is used as a cleaning agent in domestic purposes. Second, students, it is also used in the formation of manufacturing of soap, glass, etc. Students, as it is a sodium compound, it is also used in the formation of various other sodium compounds like borax, which is a very important compound. So it is used in the formation of sodium compounds, and an important sodium compound is borax, like borax. Now students, the fourth important use is that it is used in the removal of hardness of water. Let us see how it is used. So it is used in the removal of hardness of water. Students, the hardness of water is because of the soluble calcium and magnesium salts which are present in the water. And if these soluble calcium and magnesium salts are removed from the water, then the water becomes soft. And students, this hard water is actually not useful in the domestic purposes, nor it is useful for the drinking purpose, and even it is not useful in the washing purposes. It produces lots of scum in the clothes during washing. So students, it is used in the removal of the hardness of water, and hardness of water is because of the soluble calcium and magnesium salts. If we have a calcium salt, which is calcium chloride, in water, and when it reacts with washing soda, students, in this case we get a precipitated salt which is calcium carbonate along with sodium chloride. So students, this calcium carbonate is obtained as a precipitate. So students, in this way the hardness of water, which is because of the soluble calcium salt, is removed, because the salt which is obtained by the action of washing soda is obtained as a precipitate, that is, as it is not soluble in water. So I hope students, in this way the hardness of water is removed. And students, on balancing this equation I need to add 2 coefficient before sodium chloride. So I hope students, the preparation, properties and uses of washing soda are clear to you. Next we will study another salt, which is baking soda.